Hi there. Fault tree analysis is a top-down deductive approach to understanding how a series of lower-level events can combine to result in an undesired event, such as an accident or equipment failure. By creating a diagram using a set of symbols, quantifying risk, and following formal logic, a fault tree analysis helps us to understand how specific systems can fail, identify the best ways to reduce risk, and assign a risk rate or probability to a failure. The fault tree is a visual model of the logical relationship of the unwanted event to the more basic events that contribute to it. We use the fault tree analysis to methodically investigate what happens to a system when there is a change to the status of one or more elements of that system. We want to know how likely it is for specific combinations of these changes to result in an accident, defect, or breakdown. Fault trees are structured with symbols for events, gates, and transfers. The unwanted event is located at the top of the fault tree. Now, examples of unwanted events include accidents, defects in product or process, an equipment failure, or it may be a risk or potential hazard. Events in the middle of the tree are intermediate events. These are caused by other events. At the bottom of the tree are the basic events, the most elemental factors causing the fault. The logical relationship between events is shown by symbols for various types of gates. Transfer symbols may be used to connect the inputs and outputs of related fault trees, such as when a system has several subsystems. Whenever possible, we assign values for a probability of occurrence to the lowest level events in the tree. The quantitative data may be for reliability, safety, or quality. This data is used to evaluate the probability of the top event occurring. As we can see, the fault tree analysis is a top-down deductive approach that begins with a general conclusion, then works out its specific causes by constructing a logic diagram. The most common purpose of a fault tree analysis is to identify potential causes of failures before they occur. The fault tree analysis is used widely in the fields of aerospace, safety engineering, and reliability engineering. Additionally, they're used to evaluate the statistical probability that the top-level event will occur and provide more in-depth analysis to other tools and problem prevention practices. The added degree of detail that fault tree analysis provides allows us to focus efforts on improving elements critical to reliability or safety. For example, during an FMEA, or failure modes and effects analysis, we take a bottom-up approach to examine potential failure component by component rather than at a system level. This may identify certain failure modes as being high severity, frequent, or hard to detect. In such situations, the fault tree analysis is useful to evaluate these failures in more depth and with specific metrics. Fault tree analysis is used widely during TPM efforts. It serves as a foundational tool used extensively during focused improvement activities. Understanding the causes and risks of various types of equipment failures is also a key step in establishing a planned maintenance system. In the mature stage of autonomous maintenance, equipment operators often learn the fault tree analysis technique as a part of their ongoing daily improvement and skill development activity. Other pillars of TPM, such as early equipment management, safety and environmental management, and quality maintenance, all rely on insights from using the fault tree analysis method. A completed fault tree analysis helps us to visualize our understanding of complex systems, quantify the factors that lead to failures, and prioritize our efforts to improve safety and reliability. That wraps up a review of the fault tree analysis method. We'll see you soon.